accepted.
All right. Well, thank you so much for joining. Welcome to this session on refactoring from imperative to functional style. My name is Venkat Subramaniam. We'll talk a little bit about imperative and functional style, and then we'll jump into taking some handful of examples, take a look at the imperative style code, talk about what it is doing, refactor it to use functional style. So let's give it a try. And along the way, we'll talk a little bit about what are the thought process we go through as well in terms of refactoring. Well, first of all, of course, a lot of us have programmed in imperative style. Java, especially, for example, has supported imperative style plus object-oriented style from day one. In imperative style, we tell the program not only what to do, but we also take the time to tell how to do it as well. So that's a lot of effort in general. So here is my observation about imperative style. The first one is, it is very highly, you could say, familiar. We all have done this over and over and over. But what's really important for us to keep in mind is to keep in mind that familiar is not really simple. We often mistake the two. We sometimes get confused with the words. And familiar, sometimes we say, oh, that's a simple code. No, it's not a simple code. It's a familiar code. We have to be really careful about it. So familiar is not necessarily simple, not always. And secondly, because we are very familiar, I would say that it's generally, of course, it's very verbose, and we could say it's hard to really reason with the code when we are writing it. It is going to be really something which is hard to maintain as well. So in general, though, imperative style code has high, you could say, accidental complexity in general. So my observation with imperative style code is it is easy to write, but really hard to change or to maintain in the long run. So you can write it fairly easily because we're very familiar with it, but once we finish writing it, it takes a lot more effort to modify it, to change it, and to maintain it. So that's one of the problems as well. But of course, in the imperative style, like I said, tell what to do in general, though, what to do, and also how to do it. This is basically what we do in imperative style. On the other hand, in the declarative style of programming, we tell what to do and not how to do it. So we focus on telling what we want to accomplish. We use underlying libraries of code to really do the work for us, so we work with a higher level of abstraction. So we could say has, in general, you could say, in this case, reduced accidental complexity. So this is one of the nice benefits of writing in a declarative style is it's usually less verbose, and you could say easier to change as well. So the question then is, why talk about declarative style of programming here? Well, as it turns out, functional style of programming is definitely related to the declarative style. In that, I would say it's really declarative style plus the use of higher order functions. So typically, you could say, not all declarative style, you could say, is functional, but all functional, you could say, style code is declarative. So this is one of the nice relationship between the two, is that when you're writing code in functional style, you really are writing code in declarative style. That's one of the benefits you're going to get out of it, is the reduced complexity in code. But of course, we use things like higher order functions, where we can pass functions to functions or receive functions from functions. We often favor immutability when it comes to writing functional style code. We use functional composition or the functional pipeline we normally talk about. We also make use of lazy evaluation as well. So it's a different paradigm in terms of how we write the code. But of course, there are some benefits but constraints as well we have to follow. Well, enough of that talking. What I want to do for the next about 45 minutes or so is to take a few example code, talk about what the code is doing, and then think a little bit about how to approach writing this code in functional style, and then maybe to refactor it. But let's try to be really honest about it. Just a quick question. How many of us have written code in imperative style before, right? Yeah, that's almost all of us, right? And some of us are too painful to think of it. We don't want to raise the hands. That's perfectly understandable. How many of us have written code in functional style? Okay, a little bit less maybe, and a few hands waving, trying to do, I like that idea. But here's my problem, here's my journey. I started programming, roughly about 35 years ago, and I spent most of my beginning stages of programming writing code in imperative style. What I'm telling you in so many words is I had a very terrible childhood. I wrote all that code in imperative style. Then I thought to myself, maybe I should really learn about functional style of programming, and I started learning functional style. And what really made it worse is the people that are really good at functional style telling me it's really easy. And the answer is no, it's not. It was really hard for me to think functionally, mainly not because functional style is really hard, it is because I was not very familiar with it. So going back to what I said earlier, I said it's easy to write, but really hard to change. That is for the imperative style, I mentioned it. But for the functional style, I'm going to say quite the opposite, if you will. I'm going to say it is hard to write, but easy to change. And it's really hard to write because most of us are not familiar with it. So when I started programming in functional style, the first few years was extremely bumpy. And I remember one experience I would never forget. I was on a flight from Europe back to the US. It was about a 10 and a half hour flight. And as soon as I sat down in the flight, I took up code, wrote it in imperative style in about 15 to 20 minutes. And then I said to myself, I'm going to refactor this to functional style. And honestly, I took almost the entire flight to refactor it. In fact, it was so bad, the flight attendant kept checking on me to make sure I was really okay. And it was really hard. And then, of course, hours into it, a little light bulb goes into your head and like, oh my gosh, I could write it this way. And then, of course, it works. And of course, the question is, why does it take so much time and effort to write it in functional style? Well, mainly because it was not very familiar to me. It's a paradigm shift. So today, I would say, if you give me a problem, maybe 50% of the time, I can immediately think about to write it in functional style. The other 50%, I may have to struggle to really think about it. But my point is, that's okay. Don't worry about, you're not in a competition. That's what I want to really emphasize. You're not in a competition. You don't have to prove to anybody that you can write this code in functional style. So a lot of times what I tell my developers that I work with is that I'm a big fan of this mantra that I always tell myself and remind others as well, and that is make it work, make it better real soon. So it really is very rewarding first to make things work. When things work, that's a relief already, right? And then you spend the time to make it better after that. So I often tell my developers, write unit test with the code you're writing, and write good unit test and reasonably good imperative style code. Once you have that working, you can take your time to come back and refactor it. You can use others' help to refactor it. So it's a journey you can go through. And you don't have to be in a pressure to really write it in functional style in the beginning. So make it work, make it better real soon. And that's a practice. As we get really good at it, over time, it becomes easier. But again, there may be times when you find it easier to write it in imperative style, come back and refactor it. Don't hesitate to do so if you have to. Well, given that, let's talk about a few different examples here. And we'll take some really simple examples first, and then we'll go through a little bit more, not entirely complex, but a bit more challenging, if you will. So the first one I want to start with here is a little code example, if you will, and what you see here is a function which is isPrime. And as you can see, in this case, we go through value of 1 through 7, and we are printing if it is prime number or not. Well, ideally, I would have test cases, and I have unit test to pass. And again, I want to really emphasize unit test again because I'm a big fan of functional style of programming. And when I work with developers, oftentimes, in my eagerness to make the code functional, I would take the imperative style code and refactor it to functional style, and I'm about to celebrate, and then I will notice my unit tests actually are failing. And what good is your beautiful code if it doesn't work properly? And this is where my faith in having these tests is very important, because you may not really understand the imperative style code to the extent you thought you did. So having those test cases can be a really powerful saving grace, because you refactor the code, you see the test fail, it helps you to go back and to take another look at the code, understand it really well, then come back and refactor it. And so, like I said, ideally I would have those unit tests available. And if you're really interested in following that kind of a model, I would refer to the second edition of functional programming in Java, where I really take that approach to showing, hey, here are some imperative-style code with tests. Let's refactor them. And I got a few more examples in the book that I cover than what I do here. But that's a journey I would really like to take most of the time, is to really have unit test and then come back and refactor the code to functional style is a nice little cycle we can follow. But in this case, of course, I'm going to just go run the code and make sure it's producing the results I'm interested in. It says the prime numbers for 1, 2, and 3, and so on, and it's telling which is prime, which is not prime. So we have that little code running, but how do we really make this into functional style? Well, when you look at the isPrime function, what does it really do? It sets this flag divisible to false, loops through 2 to the number -1, and tells whether that number is divisible. If it is, sets the flag to divisible, and then breaks out of the loop, and then, of course, tells us the number is greater than 1 and is not divisible. So when you look at a code like this, or again, use this as an example, but how do you really approach this? So my very first recommendation is, so to go from imperative style all the way to functional style, I would say is really challenging, like I said. So one thing that has really helped me a lot is to really not make the jump. And that is to say, first of all, I would say first, think declarative, I would say, then code functional. And this really helps me a lot, and I remind myself quite a bit about it. So don't try to jump to functional style first, but instead think declaratively, then code functionally. So let's take this little problem and say, how do I really, in this particular example, think declarative? What does it really mean? I'm going to say a number is a prime, let's say, number if no number, you could say, in the range, and we could say 2 to number -1, you could say divides it. So that could be a nice way to really state the problem, to think declaratively. So rather than thinking about individual steps to take, think about what is the transformation you can do with the data. What can you think about? What is it rather than how is it? So what is a prime number? A number is prime if no number in the range 2 to number -1 actually divides it. Once you are able to formulate the problem declaratively, then you can start looking for libraries of code to really translate this to functional style. So in this case, there are some really nice keywords you can look in. One is the range, that's one giveaway, and the other is no, really, with a predicate that you have here. So given that clue, we can immediately translate this to functional style. So we could say, for example, import java dot, let's say, util stream dot. In this case, I'll bring in an int stream, if you will. And what we can do here is, first is we want to bring in the range that we talked about. So we can say int stream, you could say dot range. And there is the range, of course, from 2 to the number -1. So the range will stop one shy of the given number. So that gives us the range. So right now, what we have here is simply this part right here in the range 2 to number -1. We covered that part. So the next part is divides it, but with the word no in here. So as a result, you can simply go back here and say none match. And in this case, we can take an index, if you will, and you can say in a number mod index. In this particular case, mod 2 is equal to 0, and you can write the code like so. So as a result, in this particular case, you can rework the code from this declarative style of thinking, and then you can make the code functional in nature right after that. So when you look at this code right here, it pretty much does the same as what the other code did. So we have the range of values, and nothing in the range divides the given number. Now, of course, when you look at a code like this, it's also important to keep in mind that the functions like none match are quite efficient in terms of lazy evaluation. They're not going to plow through and evaluate all the values Instead, it is going to really look for the earliest sign that this is not a prime number, that it is actually dividing the value. It's going to bail out. So, for example, if you give an even number on just the value of 2, it's going to bail out. It will not evaluate for the remaining values in the range, so it's pretty efficient in that regard as well. So that's one way of thinking declaratively, if you will, and you can see the code is less noisy. We don't have those garbage variables that we created earlier, and we are also using higher order functions as well. So that kind of gives us an idea of how to work with the range. Let's take a similar problem here, just to entertain this thought and how we can actually solve a problem similar to this, if you will. So let's look at one more example here, if you will. So a computation of the factorial. Again, using these as an example to really think about this in a declarative style. So we have factorial of 0, 1, and so on, and all the way up to 30. And so the value, the result is a big integer. How do we really make use of the big integer in this particular case? Well, as it turns out, you can see in this case we have a big integer, and we are performing the multiply operation on it. And if you look at this code, what are we recognizing here? So a lot of times when you look at an imperative style code, what you want to do is to really think about this in terms of the declarative style of thinking, but you also want to be able to identify some very interesting and major operations in the code. For example, when you write code in imperative style, the things you're going to be using are things like a for loop, a while loop, an if condition, and so on. We're very comfortable using them. In a similar way, when we write code in functional style, you're going to be looking at things like filter, map, and reduce, and you want to see if there is any sign of these things. But in this particular example, if you notice, we are getting one result in the end, where we are taking the result and we are multiplying that result with another value. So that's a successive refinement of the value. And anytime you see a successive refinement of a value, that's immediately a clue to look for a reduce operation. So essentially what you're doing is you're taking a collection of data, but you're reducing the data to a single value. So that's a reduce operation. That is a skill we need to take the time to develop, is to look at these code, and you want those kinds of operations to stand out in your, so to say, a virtual eye, and you want your imaginative eye, and you should be able to see them here. So the minute I look at this code, I can see the reduce sitting right there. So how do we really go to the reduce in this particular code? So let's go ahead and say Java util stream. In this case, I'll bring a long stream for our purpose right now. So I'm going to say return long stream.range closed, and we'll start with 1 and up to like so. So the reason I'm using a range closed is I want that value up to be included. Range stops one shy of the value. Range closed covers that value as well. Then I'm going to say here is a map, but unfortunately though, what we are dealing with is a stream of long values, but we want the reduce to provide us a big integer. This is more of a restriction in the Java API. If you're programming in Scala or Kotlin or other languages, you will notice the reduce is a little bit more flexible in those languages compared to Java. In Java, the reduce, the first argument you pass to reduce, has to be the same type as the type of the objects in the stream. So a little technique that often helps is to say map to object, and you're performing a casting of the type so that the reduce operation is going to be happy with it. And so in this case, you can say a big integer and value of, and basically you're taking this over here and you perform that in a map operation. So even though this is a reduce operation, there's an embedded transformation, which is a map operation you can perform right in the middle. So that becomes a map operation right there. So map to object. Then you can do a reduce of big integer, and you can call the 1, which is the first value that you're going to start with that you are dealing with right here. So that becomes the initial value like so. And then you can say, here is the multiply I want to perform. So that becomes a big integer multiply as a method reference right there. So the code simply translates into a map and reduce operation like so. So once again, what we can do here is to identify those types of common operations in functional style. Like we have a map over here, we have a reduce over here, and we can translate that to those operations. And so this simply becomes a map to object with a little transformation into reduce for the initial value of 1 and a multiply operation as well. So that was, again, relatively easy and simple to work with. Nothing really complicated, as you can see. Let's go a little further with this. So in this particular case, we avoided mutation. We made the code really expressive, easier to work with as well. Now, one other example before we get to a little bit more complexity is in this particular case, I want to work with a collection of, let's say, a data from a file I want to use. So a very simple example here. So we have a search word, and the search word is localhost. I'm going to search for it in the host file as an example. And what are we doing in terms of knowing how many times that, or how many lines that does that word appear in the file? So we have this very scary code we have written in the past, isn't it? So a string line equal to null, and we say while line is equal to buffered reader read line, which is not equal to null. This is the kind of code that you hide from your family members, right? You never want anyone to see this kind of code. It's pretty scary. And so we just ask for a null check every time, loop through it, and if the line contains the search word, increment the count, and so on. So when you run the code, you notice it says we saw 3 occurrences of it. So the question really is, how do we go about really transforming this particular code? So we don't want any explicit mutability, but when you look at this, though, if you, for a minute, think about what we're trying to do, we have lines of strings. We want to be able to know how many of those lines contain the word we are interested. So clearly we can see that given a stream, we want to filter the data, and we want to perform a reduce operation, but it's a specialized reduce, which is the sum operation, or rather, pardon me, a count operation in this particular case. So a count is a specialized reduce operation. There's only one missing link at this point. If we're given a stream of data, we can filter the stream and do a reduce operation, in this case, a count, but how do we get a stream of data? So the next question then is, given a file's content, how can we get a stream of data from a file? So that will help us to search through the JDK or other libraries to see if there is a way to take a file and push a stream out of it. And as it turns out, there is a beautiful function you can use under the NIO file, dot files, if you will. So what you can do then is you can simply come over here, and you can say a count is equal to, and you can say files.lines, and you can then ask for paths.get, and this is going to be the path you are interested in. And you can simply take that one. Let's start with baby steps right now, if you will. So let's get to that in just a minute. So if I were to say in here, let's say lines, and paths.get, and I'll put the path in there. If I execute that code, what am I going to see in this particular code? So when we take the files and we ask for every line in the file at this point, and we then ask for that to be on the path, notice that says it's a stream, a reference pipeline. So what we know from this example is that this gives us a lines, which is a stream, is the result of it. Well, gosh, if that's a stream that we really have, then what we can do is we can take that and we do a filter, and we can give a line and say, in this case, line.contains, which is this one right here. So we can say contains, and we can ask for the search word from it. Then the last step is to get the count, which is the reduce operation, which is incrementing the count right there, and we can simply ask for the count to be given for us from that particular code. So that becomes a very easy easy way to do it. So essentially, the idea here is that we get the stream of the data from the file, and then we can do a filter operation, and we can do a count on it. So that becomes a very easy way to implement that as well. So again, these were fairly simple examples. We were able to translate them. Now let's go to something a little bit more of an effort, if you will. So here is one scary piece of code I want to start with right here. And when you look at this code, what you are seeing in this particular example is that you see that it says, this one actually, let me see if this is the one I want to work on. So I want to come back to this. So pardon me, let me switch over here. I'll come back to this example in a minute. Let's go over to something a little bit complex in what we do. So here is a code that somebody actually asked me about. And I want you to think about this for a couple of minutes, if you will. Because sometimes the simplest of things are the hardest things to do, as they say. So here is an example of a word hi. And I'm asking for a find in, and I give a hi to it. We'll talk about what find in does in just a minute. Similarly, we pass a hello. We pass another word and another word and another word. We're passing a few things in here, but what does find in actually do? So when I run the code, for hi, there is no result. It's an empty response. For hello, it is a L, and the reason it's a L for hello is L is repeated. So find in is telling us the first repeated letter. Let me emphasize, what does it mean by first repeated letter? So if you say a persevere here, R is being repeated, so the result is R. When you look at Jaguar, A is repeated, so that's also easy. However, when you look at hello there, notice H is repeated, but L is repeated, but so is E. But in this particular case, the result is a H because H is the first letter that is actually repeated. So the problem is actually extremely simple, logically speaking. You just want the first repeated letter in a given word. So what does this code actually do right now? I have to say this code is relatively simple compared to the code that somebody sent me. And what they had done, to find the first repeated letter, they had created a hash map, and then they had populated the hash map, and then they started navigating through it. So that was about 25, 30 lines of code with a lot of complexity in it. But in this particular case, it's an imperative style code, but what are we doing here? So we are saying, hey, give me all the letters in the word, and once you get me the letters in the word, I want to start with one letter at a time, and I set the count is equal to 0, and then I say for that particular letter, go through all the letters again. So we have a secondary iteration and a nested iteration. And if the candidate that we are looking for is the letter, we increment the count. And if the count is greater than 1, that tells us the letter is duplicated. So we just return that letter, and we are done with it. So that's the imperative style code. Again, what we want to do is to return the first letter that is repeated, right? So nothing is repeated here. L is repeated here. R is repeated in this particular case. Even though E is repeated, R is the first one, so R is the result. A in this case, whereas here, H, because H is repeated, it's the first letter, and E is repeated and L is repeated, but H is the first one that's repeated. So how would we go about solving this particular problem? I'll just give it a couple of seconds, maybe a minute for you to think about. If anyone wants to yell out an approach, feel free to do so. How would you solve this particular problem? So how do you deal with the first letter that is repeated, right? So like I said, the approach somebody took was they created a hash map. And then they went through the hash map because they wanted to iterate once. They don't want to iterate twice. The disadvantage in the code I have is that it iterates twice, right? So they iterate once, they create the hash map, and then you go to the hash map and see how many of them have a value greater than 1. And now you're like, oh, so that's duplicated. And now you're like, let me find the first one. So I'm sure your mind is racing through all kinds of possible solutions, right? But as it turns out, there is a very simple way to solve this problem. And as they say, simplest things are the hardest things to think about. And maybe you thought about the simple solution, or maybe you'll think of solutions simpler than the one I'm going to show you as well. If you find a solution simpler than what I'm going to show you, I hope that you will be able to come and share that with me. But if what you thought about is a bit more complex than what I'm going to show you, that's something to really rethink about it. But before we go further into it, there is one other thing I often do. We all use IDEs oftentimes, and don't get me wrong, IDEs are great. For any serious project, we want to use IDEs. We have documentation that's great as well. We can keep looking at documentation. But fundamentally, though, I feel like a part of me as a programmer is not about writing code, but it is about experimenting. So to me, if you ask me what is programming, I would say programming is a series of mini experiments where we convert a series of unknowns to a series of knowns. So oftentimes I'm curious, how does this really work? In a way, that's the part of me as an artist as I write code, even though as an engineer I write code. Generally, what do you notice a painter? If a painter is painting something, they just don't take paint and sling it on and paint it. Some of them do, but not all of them. But instead, they are trying to really see how the paint is. They try to get the right amount of paint, and then they go off to paint it. So that aspect of experimentation to me is extremely critical. So here is something I want to show you. What I typically do is I would typically bring up a J shell. You can do this in the command line, but you can also do this within your IDEs where you can open a terminal and you can jump to a shell, if you will. So if I say string, let's say sample, we'll just say s is equal to, let's say hello, like so. And I can say s.index of, in this particular case, and I can ask the index of h, if you will, and notice the index is a 0 because that's the first letter. If I ask the index of L, on the other hand, it's a 2. So far, so good. But then I say last index of, and in this case, I'm going to ask for h, and it turns out that's a 0 as well because h is not being duplicated. But if I say s.last index of, and in this case ask for an L, notice that it's actually a 3 compared to a 2 that we got in the index of. So that gives us an idea what we can do. So that experimentation can lead us to thinking about this in a more of a functional style, if you will. So what we can do here is we can say a return, and we can take the stream off, and we can take the word and we can split the word on every letter. And now that we have a stream, we can then say filter, and given a letter, we can say word.last, let's say, index of, the letter is actually greater than word.index of for the letter. So obviously what we know from that is that if the index is different, then we know the letter is duplicated. If the index is not different, then it's only appearing once. Now that we did this, we can simply say find first, and if it doesn't exist, we can say or else, and we can ask for an empty letter out of it as well. So that becomes a very easy way to get that working for us. So in this case, we can go back to the stream and ask for the letters and find the letter that's duplicated, and then only find the first one. Otherwise, give me an empty string, and we can implement that very easily like so. So once again, in this case, we can think of a lot of complex ways to do this, but as it turns out, it actually is fairly simple, maybe even trivial once you think about it. But really, the idea here is the find first. And the find first function really is really useful because it is lazy evaluation. The minute it finds the first one, it's not going to evaluate the rest of the letters. So in this particular example, it would never evaluate the S, E, V, and so on. It is going to stop as soon as it evaluates the R, because that's what the find first does. Is it's going to quit immediately. It's a lazy evaluation. equation, it's not going to go process all the values, so that can be a nice way to implement it. Again, like I mentioned, when you look at this problem, our mind races to all kinds of possible solutions, but then sometimes it's really simple to solve it. And if you find something simpler than this, I would love to learn from that. But this is one of the things you can do to really minimize the amount of effort you need to put in for that kind of code, if you will. So that brings us to one other example I want to talk about here, and this is also a code that I received from somebody, and their email was, hey, I looked at functional programming, I know how to use filter, I know how to use map, but I'm not exactly sure how to solve this particular problem. So I want to show you the code first, and then we'll talk about how do we go about solving the problem in here. So if I look at this code right here in this particular case, I'm going to actually bring the triple function here for a second. So this is a get triple, if you will, and this is going to bring in, let me see if I have it right here. So this is going to be the get triple, that's the seventh one, I'll bring that in here. So let's go ahead and bring in the code first of all, and take a look at what it is doing. So there we have the code. So what am I going to do with this particular function? So you can see in here, it's using a Euclid's algorithm, so not very complex code. It's a nice little way to think about these points in here. So the idea behind this is you have a value of, let's say, A, B, and C, and the idea here is you want the value of A, B, and C that satisfy that particular equation. So where A squared plus B squared is equal to C squared. And there are infinite number of values that satisfy this particular equation, but the question is, what are those? So how do you find it? The good news is there is already a bunch of algorithms. One of them is a Euclid's algorithm, which is doing it, which is what you see up here. So what this algorithm says is, you're going to give it a value of m and n, and when you give a value of m and n with the requirement that n is at least equal to m or greater than m. So then a value of a, b, and c for those values of m and n are these values. And then, of course, you can find the a, b, c as the value, and you can return it. So here is a compute triples function, and what the function is doing is, it starts with an empty array list, and we want so many of those numbers given to us. So what we are doing here is, we are creating an empty array list, a count is 1, we start with the m equal to 2, that's a requirement for the algorithm, and it's going on to m plus 1, and 2, 3, 4, and so on, and you have an n starting with a value of 1. It goes up to m, I stand corrected, it should be up to a maximum of value of m minus 1. So in this case, you have triples, and get triples, you pass the m and n, whatever value it returns, you add it. Increment the count. If the count is greater than the number of values, you break out of the loop. And unfortunately, you have to do it one more time based on the way the code is written. So you check for count greater than number of values, and check again. You break from the inner loop, you break from the outer loop. So when you run the code, the output is the following. We only wanted 10 values. If you notice right here, we are asking for 10 values in here. So when you run the code, you got all these values. Notice 3, 4, 5 as the first value. I'm going to note this down here, 3, 4, 5. And the last value that you see in here is a 9, 40, and 41. And so those are the values that we are getting. And of course, other 8 values in between. So the question is, how do we write this code in functional style? So when you look at this code, anything comes to your mind when you look at this code? Nothing yet. So what you want to do when you look at this code is, you want to notice a particular structure in this code. When the person who wrote the email to me said, how do I write this code in functional style? And when I looked at this code, I had the advantage of spending a few years on functional programming by the time. Like I said, if this was something I received in the early stages of my functional programming experience, I would have struggled with it. But when I looked at this code, I noticed something a little bit different. And I'll come to that in just a minute, if you will. So let's take a pause on this. We'll come back to that and take a look at it. So let's take a little detour, and I'm going to take a detour mainly because Java doesn't quite have it, but we have this in Kotlin, and then we'll come back and talk about this in Java with a little bit more example here. So let's take a look at this little example in Kotlin real quick. So I'm going to say numbers is equal to list of, let's say, 1, 2, 3. Yeah, that's good enough to begin with. So I'm going to say in here, numbers dot, let's say, map. And in this case, I'm going to say, given an element, I want to return element times 2, let's say. And I'm going to store this away in here as, let's say, result is equal to, and let's go ahead and print this result. A very simple piece of code here, isn't it? So nothing really complicated. So when you run this code, you can see 2, 4, and 6, that's not a problem. However, if I were to go back to this code and say, I don't want to return a times 2, but I want to return a list of element minus 1 and element plus 1. So when I return this, what does the result show? The result is a collection of collection, isn't it? So in other words, we're not getting one collection as a result, we're getting a collection of collection as a result. So I want you to think about this in terms of a one-to-one a mapping. So what I mean by one-to-one is, example is E times 2. Given one input, you got one output. So when you do a map operation, what happens? You go from a collection all the way to a collection. So that worked remarkably well. Then I want you to think about a one-to-many mapping. So when a one-to-many mapping is, you actually return a list of something for a given value of E, like so, right? So when you give a value of E in this particular case, you are not returning a E times 2, but you're returning a list of something as a response. So that's what we just did here in this example. We given an E, we return a list of elements. So what's the result of that? The result of that is map will give you a collection. You would be returning a collection of collection. And the chances are that's not what you want. Let's take an example real quick to think about it. Suppose you are given a collection of people, everybody in this room, and if everyone has, everyone here has a first name, I can do a mapping. Given a collection of people, I want the collection of first name. But if I want everyone's email addresses, you may say, which email addresses? Well, if I'm going to spam, I might as well get all your email addresses, right? So that's a one-to-many mapping. So every single person gives me a collection of emails, if you will. So in that regard, it's going to be a one-to-many mapping. So we go from a collection to a collection of collection, right? That's what we end up with. So how sad that is. But what if I really want to use a one-to-many mapping, but I want to go from, let's say in this particular case, so one-to-many, but I want to go from, in this case, a collection, if you will, but to a collection, not a collection of collection. So the question is, what can we do in here? We'll get to that in just a minute. But going back to this example, if you will, when I run the code, you can see the result is a collection of collection. What I can do is I can say result 1, and I can take the result 1, and I can then say val result is equal to result1 dot flatten, and I can ask it to flatten the result at this particular point. So notice in this case, we flattened it, and we got a collection, which is a one-level collection, not a collection of collection. So just to emphasize this, if I have a result in here and not a flatten, we have a collection of collection as a response. As you can see right there, 0, 2, and 1, 3, and 2, 4 are the collections sitting inside this outer collection. But instead what we are doing is we are asking it to give us a flattening, and as a result, we got one flat collection in the output. So far, so good. Now you say, but wait a minute, you took 2 steps to do this. Why can't we do this in 1 step? That's a very reasonable question, isn't it? So I'm going to go back and say, here is a result, and I want to do an operation here where I am doing a one-to-many operation, but I don't want a collection of collection. I want a collection. But I want you to think about this very carefully. Don't rush. I want to do the map, and I want to flatten. So if I were to write one combined function to map and flatten, what would be the most logical name for that function? Logical name. Don't give me what you have read. What would be the logical name for it? It would be map flatten, isn't it? I challenge you to do this. Go ahead and try it. Go ahead and say it. Map flatten. Come on. Say about 3 times for me. What did you notice? A sharp pain right here in the jaw, isn't it? Because when you say map flatten, your jaw goes through this awkward movement. Try it a few times. Map flatten. The people who create this API are geniuses because they figured out if they called it map flatten, in 300 years, you will have humans who evolved very differently because of the jaw movement. They're not only geniuses, they have humanity. So they called it flat map. Go ahead and try it. Flat map. Notice how it rolls off the tongue. The jaw just slides over once and stops, right? So they saved our jaw while naming a function. That's the brilliance of this. So now you know the rest of the story. There is nothing called the flat map. Is actually map flatten without breaking your jaw. So that is basically the whole idea of it. So you map it, and then you flatten it. So what you want to do is when you look at some code, you want to look at that code and ask the question, is it a one-to-many operation? So when I saw this code, what did I see here? I saw a one-to-many operation. So what is that one-to-many operation? When you look at every value of m, you get a many values of triple for one value of m. So the minute you see a one-to-many operation, you know it's a flat map operation. So you want to really map it, and you want to flatten it. So going back to this code here in Kotlin, if you will, the combined operation, as I mentioned, is a flat map, isn't it? So you can say a flat map like so, and it gives you, in this case, one collection, not a collection of collection. Even though Java doesn't have a flatten operation, thankfully it does have a flat map operation. So the minute you recognize it's a flat map operation, what are we going to do? So now you can say, aha, I can say return, and I have values of m that I want. So we can go ahead and bring in here, let's say a stream, and we can even bring in an int stream from here. So we'll say int stream like so. And now that we have an int stream on our hand, what we want to do here is to say return int stream dot range closed. And well, in this case, we want a range, or actually in this case, we want to keep iterating the value, pardon me. So what I can do is I can simply say stream dot iterate, and we'll start with the value 1, or rather 2. And why 2? Because remember, m is starting with the value of 2 right there in this call, as you can see. So we start with the value of 2, if you will. And then what we can do here is we can say, given the value of 2, I want to say, given an m, give me an m plus 1. So this line here literally becomes this infinite stream right there. Then we can perform a map, but because it's a one-to-many operation, we can do a flat map. So we take a given m, and what are we going to do with it? Then comes the inner loop, as you can see right there. So we can say in here comes the int stream dot range, range in this case 1 to given m. So we go from 1 to the given m. So we have an int stream. Then we can do a map to object. And in this case, given a n value, we can return a get triple for the m and n as a value. So this becomes a flat map operation because you have a one-to-many mapping. Here's the outer loop, and here's the inner loop, which contains many values for it. Then what are we going to do? We are really interested in all those values, but we only want certain number of values, so we can do a dot limit, and the limit is going to be the number of values we want. And at this point, we can simply say collect, and we can simply collect it to a list in this case. We can simply say a to list, if you will, and that gives us a list of all those values, and we can get rid of that giant code. So basically, the idea behind this is we create an infinite stream, we do a flat map operation on it, we get the map to object for the triple, and then we get that many values, and then we return the list of those values in the end. And you can see the first value is 3, 4, 5. Last is 9, 40, and 41, exactly like the way it was. A very concise code, but the trick is to recognize that this is a flat map operation. What you want to be able to see there is the one-to-many operation, and immediately, that's a flat map function rather than a map function. That can be a nice giveaway, if you will, where you can find and perform that mapping like so. So essentially, the idea here is, like I started out saying, I find that writing imperative-style code is easy, mainly because of my familiarity with it over the time. However, I would argue that functional-style code is easy to maintain in the long run, and as a result, you can make it much easier for the journey. If you're interested, you can download some of these examples from my website as well. That right there is the link. I hope that was useful. Thank you so much.